Good afternoon, everybody. Welcome to this session, and thank you very much for your interest in my talk about natural language generation in dialogue systems. My name is Diana Mengels. I am head of anology at Capital One Bank. My background is a combination of mathematics, linguistics, languages, natural language processing, and machine learning. My goal is to create a new generation of anology components that would draw upon the principles of how language comprehension and language production work in human brain. At Capital One, we are developing a chatbot named Eno. Here is the logo in the corner on the bottom. Eno was introduced to the market in March 2017. And today, Eno is on its journey towards becoming a full-fledged personal banking assistant that will help our customers to have engaging conversations about their money, spending habits, and accounts, and general questions about banking. So let's jump in and start with the definition of natural language generation. Anology is a subfield of artificial intelligence that is responsible for a language production function in a software application. And there is a wide range of anology systems that exist today, but they all have one thing in common. What they do is that they take your data and they transform it into text. And this text can be personalizable, they can be targeted at different audiences, and they help large companies to create more engaging experiences with their customers. Besides that, they help to automate tedious processes of report generation. And a lot of large companies are saving a lot of money by incorporating anology software into their daily workflows and having anology software doing the job, or doing big part of the job of data analysts and data scientists that have to create, otherwise would have to create these reports manually. So this is a traditional, conventional anology, but today we are going to focus on anology for dialogue systems. Anology for dialogue is relatively new. It's very unexplored compared to other fields, other components of dialogue systems, such as natural language understanding and dialogue management. So anology in dialogue has its own unique challenges compared to traditional anology. Anology in dialogue is responsible for real-time communication with the user. Not only does it have to convey a certain message, but it also has to do it in a very dynamic, adjustive way. It has to produce coherent answers, and it has to be easy to comprehend. Most of the things are not happening today, because today anology is predominantly relying on a static template-based approaches where dialogue designers define the answers in advance, and these answers are being used over and over again with any kind of questions, with different ways of how people ask different questions. So let's have a look at the dialogue architecture and anology place in this architecture. So it all starts with the user over there. The user speaks or texts the system, and then it goes, in case of speech input, it goes through automatic speech recognition, and then it enters natural language understanding module right here. Natural language understanding is responsible for understanding of the request, and after the request was understood, it goes into dialogue manager. Dialogue manager is basically the brain of dialogue system. It decides what to do next, what to ask next. And then dialogue manager sends instructions to anology, asking anology to display certain message or ask another question. So let's zoom in a little close and have a little closer look at how NLU and anology work today. So here is NLU. And I think it's not a secret for most of the people in this audience that NLU is not trying to understand every single word of what we say. It rather thinks in categories. So we have these intents that are defined by dialogue designers in advance, and each dialogue system can only handle a finite set of intents. And another way of representing it is via the bucket approach. So we have this set of buckets on top, and the job of NLU is to find the most relevant bucket for user's request. So, for example, if user is asking, is it going to rain tonight? NLU's job is to find the bucket that is responsible for requests about rain. So, and when NLU finds this bucket, it dumps this request into this bucket, and we forget about how the question was asked. And all the following components, all the following processes that happen in dialogue systems, they act upon those buckets. So we don't know anymore what was the question. We just know that it was something about rain tonight, in this case. So this approach works very well, especially for voice control applications where you don't need to answer anything to the users. For example, when I say turn the lights on or turn the lights off or play music or stop music, this is all easy and this is all handled pretty well by NLU today. But when it comes to actually answering to users' requests, to answering questions, it becomes more difficult and becomes more evident that we don't get enough information from the bucket. We actually need to know much more about how the question was asked in order to create dynamic and contextual response. So today, most of the dialogue systems don't know anything about how the question was asked, and we are kind of forced in anology to display a very generic answer that we assume will fit into any context and will work fine with any way of asking the same question. So if I ask, is it going to rain tonight, or will it rain tonight, or what's the situation with the rain tonight, I will still get the very same answer that was predefined and pre-written by dialogue designer manually. So we know what was asked, but we don't know how it was asked. And this is the main obstacle in moving, in pushing anology on the next level. Now let's have a look at how anology works today. So anology is predominantly relying on templates. And templates, you can think of them as the functions with variables that get instantiated at runtime with actual values. So in this case, on the second line, we have an example of the template, and it has these placeholders for daytime, city, actual temperature, and sky state. So at runtime, when our APIs fetch the real data for this particular request at this point of time, this template gets instantiated with those actual values. So, and I can ask this question in a very different way. I can say, check the weather, what's the weather, is it sunny, is it cold? And all those questions that ended up in the same bucket, they will have the same answer over and over again. So this, most of the limitations on anology are imposed by natural language understanding, by the way we do it, because we generalize the meaning and we don't try to understand every single word. But there are certain things that we can do already today to make our answers fit better into the context. The first thing that we can do is to create more granular buckets. If we have smaller buckets, we can have more specific answers. So in this case, if I ask Alexa, is it sunny, I'm still going to get the same answer as if I ask just generic question about weather. But if I ask Google, is it sunny, Google is actually going to answer me, yes, it's currently sunny in Tyson's Corner. That's where I live. So we can see that if we create more specific intents, we can create more specific answers. But this is also not a very scalable approach, because at some point we will hit the wall there too, and we cannot create a specific intent for every single utterance we can ever imagine that user can ask. Then it defies the purpose of having the buckets in the first place. Another way of improving your answers is to create more variation in the answers. So instead of having just one generic template, we can have a number of templates with slight variations in them. And that will create a more human-like impression. So whenever you ask the same question multiple times, or you come back to the system and ask it again, it's actually gonna tell you answer in a slightly different way. So if I ask Alexa, is it warm outside? Alexa is going to give me the same answer as if I would have asked about the temperature. And we can see here that it's extremely difficult for our dialogue systems to answer simple yes or no questions. And the reason is that exactly that the same bucket approach, because In this case, for example, the template that Alex is using to answer this question has to fit into all the contexts. So it has to work if I ask, what's the temperature outside? And it has to work if I just ask, is it warm outside? But those questions are of completely different nature. And the first one assumes a yes or no answer, and the second one doesn't. But we can't cover both situations in the same template. And that's why we have to go for a more generic variant. Google does have a specific bucket, again, for this question. So the answer looks much better because at least it starts with yes or no. But then the bucket approach reveals itself in the fact that Google is using a different word from what I have used in my request. I asked, is it warm outside? And I get an answer, no, it isn't hot outside. So there is a mismatch here, and it happens exactly for that reason, that we don't know how the question was asked. So you can imagine a situation when you cannot talk to a person directly, but you have to go via a person's assistant. And this is how your original request gets distorted, and the person on the other end doesn't know how you asked it, but the person knows what you asked about, and then they send you a very generic reply. And finally, the most sophisticated way of doing NLG today is probably by combining smaller templates together, reordering them in the most appropriate order, and thus accomplishing the goal of trying to fit it nicely in the context. So in this case, we can see that I asked two very similar questions to Google. The first one is, what's the weather like today? And the second one is, what's the forecast for today? So they're pretty similar, but they do end up in different buckets because Google NLU system is very detailed and fine granular. And also, we kind of see that they're using similar language, similar templates. They just display it in slightly different order to put the most relevant information in the beginning and the less relevant at the end. So this is a more dynamic approach. We can reuse certain templates. We don't need to write everything again from scratch. But once we try to make our atomic pieces smaller and mix and match them together, we start seeing new issues. We start seeing a lot of repetitions, for example, or inappropriately used pronouns. And this is something that we have no way of handling yet today, and some additional post-processing techniques need to be run. But yeah, NLG is, as I said, NLG is pretty young, and it has still a lot of things to accomplish and a lot of problems to solve. So we all know that NLU benefited tremendously from deep neural networks, big data, and computational power. NLU just 10 years ago was predominantly rule-based, and today we train very powerful machine learning algorithms that can provide you with a very fine-grained classification. But NLG, nothing really happened to NLG. Still today, we are writing manual templates, writing manual answers. We're asking designers to provide everything in advance, and there is no automated way of doing it. So why is that? So first of all, there is a very easy and safe alternative to do that, templates. You put your template once in there, and you're sure that this is always what your system is going to answer. There is nothing non-deterministic happening, and you're sure that it's not going to offend anybody. Also, the high visibility of NLG output imposes high expectations. So whenever we try to experiment with deep neural network approaches, we end up with misplaced commas, with weird words here and there, and sometimes with just nonsensical output. And we cannot afford doing that with NLG in a real product, because it will put your reputation, your company's reputation at risk. Also, non-deterministic output obviously is a high risk for companies, especially for those companies that are highly regulated. And for example, Capital One is one of them, or any institution on a fintech. Another reason is a different nature of the task itself, different nature and different complexity of the task. If we read books on psychology and neuroscience, we will find out that for human beings, recognition tasks are normally much easier than recall tasks. And recognition means one of the recognition tasks is natural language understanding. And when I say recall, I mean that this is one of the tasks when you have to create something new. So natural language generation is basically one of those tasks. When you have to create something new, when you have to recall somebody's face and describe it, when you have to recall the message, the image and describe it in natural language, these are recall tasks. And they involve much more complex processes in our brain than when we have to understand something or discriminate between different categories. So if I ask you, if I show you somebody's face and I say, this is Alice, you're going to remember, okay, this is Alice. But if I ask you, how did Alice look like, it's going to be much more difficult to remember and to describe that. So the nature of the task itself is very different. That's why deep neural network approaches are not as effective and not so easy in case of natural language generation compared to natural language understanding. And also, finally, we have a very little understanding of what a good answer should look like. Intuitively, we understand that in this case, we should have answered yes or no, rather than just given a generic kind of information, not directed at user. In some cases, we know that, oh, we should have said this word first and leave everything else for later. But in many cases, we do all these things subconsciously. We don't realize what kind of rules we follow. And there is no such magic book that will describe you that this is how humans speak and this is the right way of doing it and this is how it's going to be perceived more natural. And this also makes NLG task very difficult. It's difficult to evaluate what answer is better than the other. And we need to work on creating such metrics by leveraging research from psychology and neuroscience. As a summary of NLG today, we can see that we have, on the upside, we have very controlled output. We can always test everything exhaustively. We know what our chatbots or our dialogue assistants are going to answer at any point of time, regardless of the input. We always have grammatical and well-formed utterances. But on the downside, we don't have any variability in our answers. And also, our answers do not always fit right in the context. Another problem with template-based approach is that it's very difficult to scale and it's very difficult to reuse certain pieces that you have already written for other similar scenarios. And this becomes especially important when you're trying to impose a certain character on when you're trying to personalize your chatbot and you want it to speak a certain language, you want it to be consistent. So this becomes extremely important in those cases. And what we have to do now, we have to write everything manually over and over again. And as your chatbot scales, it has more and more intents and it has more and more answers, and it becomes even more difficult to keep track of all of them and create this kind of consistency. So how I see future of NLG is that NLG is a highly interdisciplinary field. Today, we are predominantly focusing on the software engineering perspective of NLG, but there are also important factors that play a role there, and there are a lot of studies and a lot of insights that we can gain from linguistics, from discourse, from psychology and social interaction theories. So this is perhaps the most exciting one because I'm very interested in the way our brain works. So the scientists used to believe that there are two separate areas in the brain. One of them controls language production and another one controls language understanding. And they used to believe that these processes happen predominantly separately in our brain. But more recent studies actually proved that that area that is heavily involved in production during the language production process also gets activated when we are trying to understand something very complex. When there is a long relative clause, for example, or when there is some ambiguity in the input, this is when this Broca's area gets activated during the comprehension. And this is another proof of the fact that we cannot keep looking at NLU as separate from NLG. We have to come up with a better approach to take more knowledge in terms of understanding from the input utterance and incorporate it into our natural language generation models. And it also proves again that language comprehension task is easier than language production. Another interesting research is going on in psycholinguistics field. We all know that when we learn a language, we usually start talking much later than we start understanding. The same happens with our children, and the same happens with us when we learn a foreign language. This is proving again that it takes time for us to be able to produce coherent output before it takes a lot of time, and we first start understanding language, and we need to collect more and more data before we can produce. And there are two main strategies in terms of how we learn languages. One of them is rule-based, is where you sit at home with your grammar book and you're trying to memorize all the rules, and then you're trying to apply them when you go out in the world and communicate with the people. And on the other side, we have a completely different strategy when we do go out in the world without knowing anything about grammar, words, lexicon, vocabulary, syntax, or anything else. And we just listen how people communicate, how they express their ideas, and we try to do the same ourselves. So those two strategies do not work well in isolation from one another. And normally, we really start speaking the language when we know a little bit of both, or maybe not even a little bit, but a lot from both. And this brings me to my next point, that we have a similar situation in software engineering world. Almost every AI task had traditionally rule-based approaches, solutions, and machine learning-based solutions. And in case of anology is still predominantly solved by so-called role-based solutions. And it's extremely difficult to incorporate deep neural networks on their own without having a backup via rules. So many industries and many attempts constantly keep rolling back to template-based approaches because of the complexity of the task and the risk it introduces once you switch to something that is much less controllable and non-deterministic. But the future of NLG should combine both. It should basically take the best parts of the two approaches and combine them harmonically together. And also, my last point I want to make here, I don't have too much time left, but in psychology, neuroscience, and discourse, there is a number of studies, very interesting studies, that explain why we choose certain way of answering questions, why we choose certain word order or certain words to express our ideas. But all those theories basically agree on one thing. When we talk to each other, we create one shared space where we share our vocabulary, our memory. We have one common plane together. We build our concepts and entities mutually, and we both contribute to the same space and to the same conversation, which basically proves again the fact that natural language understanding and natural language generation cannot be considered as two separate bodies, and we really need to try and create this common space when we design and interact with our chatbots. So finally, the way I see the future of NLG is, first of all, we have to bring the expertise from those different fields together to solve this problem, rather than focusing on software engineering aspect alone. We also need to define metrics and characteristics of what exactly the better NLG is. How do you measure that this is better than that? We also need to rethink and revamp how we do NLU today, because the bucket approach proves to be not enough to create this real, natural, and human-like experiences in terms of NLG. Another interesting way to go would be to create out-of-the-box NLG solution that can be integrated in chatbot frameworks such as Amazon Lex or Google Dialogflow and many others that exist today on the market. We do have already out-of-the-box NLU, we do have out-of-the-box dialog manager, but we have nothing for NLG. And finally, when we move ahead and when we push NLG to the next level and it becomes more natural and more dynamic, we also need to think how we're going to test these new outputs. We have to change the way we design for NLG, the way we develop our chatbots, keeping these things in mind, and we have to come up with the new strategies in terms of how to test this highly variable and highly dynamic kind of system. And this is basically all I've got. I think we have a couple of minutes more for questions, but otherwise feel free to find me after the session and I'll be happy to chat about it. All right, any questions? Yes, please. Yeah, you.
So in this slide, you talked about the hybrid rule-based ML approach, and one of the things I'm curious in terms of NLP, do you also have any like adaptive techniques for these models? For instance, sometimes when humans converse, they can, for instance, like I'm just trying to say, if I ask you a question and you answer it, you may respond that I answered your question, and I can better inform and assist in your response by giving you some feedback. In NLP, do you have to kind of feedback techniques that can assist you better inform the system?
Well, the point about NLG is that it's not acting in isolation. We have dialogue manager and we have natural language understanding that keep track of the conversation history. And normally it's all going to be expressed in the dialogue state. And dialogue manager will send instructions to NLG that, oh, this is what I've got, this is what we know, and you only need to say this. So NLG is more about the language itself, how you formulate the same message in different ways, and how do you adjust it to the way user asks the questions. And deep neural network approaches are extremely good in capturing this superficial fluency of the language, but what they're they're very bad in capturing the meaning. So you can generate texts that look very natural, but they make no sense. That's why we keep rolling back to the template-based and these kind of hard-coded solutions. And my main point is that we need to try to integrate this superficial fluency into the carefully designed template-based approaches and combine them together in such a way that it will create a natural kind of conversation. 3 more minutes, if any questions. Yes, please. Thank you. You mean multiple intents when we have multiple intents questions? Yeah. Yeah, that's exactly what is extremely difficult today with template-based approaches. And most of the NLU systems, they only able to assign one intent to your request, and then they only render one answer. But if we rethink the way we do NLU and make NLU on the first place more dynamic, that it returns more fine granular information, then analogy can act upon those pieces and actually generate answers based on them, even with template-based approaches. Even if we keep sticking to the templates, let's say we receive 2 buckets instead of 1 bucket, then we can combine these 2 answers together. But of course, the more dynamic and the more engaging experience will only come if we truly try to understand the question in a better way and truly try to address the surface form of the questions, but not only the actual intent that was returned by NLU system.
The other part is
NLG doesn't? Yeah, exactly. We forget immediately about what we have said. That's another problem. We don't remember what was previously said. We are acting, we live in this moment now, and we can't efficiently refer to something that was mentioned before. That's another problem. All right, I think I have to leave the stage, and the next participant is probably here, or I can stay as well. All right. So if anybody has any more questions, please come find me, and I can answer it right now.